Hello and welcome to another video of Math Olympiad question series. In this video, we are going to solve one of exponential equations we are given, that is 4 raised to power a minus 36 raised to power b equals 28, and where a and b both are positive integers. So the first question that comes to mind is how we are going to solve two variables in a single equation. That is, there are two variables a and b here. So how we are going to solve these two variables in a single equation? So let's start the approach to this question. Before that, we need to have some exponential rules. We need to know the exponential rules. So basically, if a raised to power m raised to power n can be written as a raised to power m and n multiplied, can also be written as a raised to power n raised to power m. So we need to write 4 raised to power a and 36 raised to power b in such form that they form the smallest integer values. So let's write 4 raised to power a can be written as 2 raised to power 2 raised to power a, and 36 can be written as 6 to the power of 2. So we can write like this, 28, right? Now if you see, 2 raised to power 2 using the exponential rules can be written as 2 raised to power 2a minus 6 raised to power 2b equals to 28. Now again, using this, we can write 2 raised to power a raised to the power 2 minus 6 raised to power b raised to power 2 equals 28. As in algebra, we are taught that x square minus y square can be written as in the product form or the factored form as x minus y times x plus y, right? So how we are going to write x square minus y square in this equation? So 2 raised to power a is your x and 6 raised to power b is your y. So this can be written as 2 raised to power a plus 6 raised to power b times 2 raised to power a minus 6 raised to power b equals 28. Now the next question arises how we are going to solve these two factored expressions in the form of such that we can find two equations to form. We need two equations to solve two variables, that is a and b. So how to form two equations out of a single equation, I'm going to show you in this question. So 28 can be written in the factored form or the product form as 28 can be written as 1 times 28, right? Also 28 can be written as 2 times 14, right? And also 28 can be written as 4 times 7. Now if you see, out of these three forms, one of them would be the ideal pair to write 28 in this equation. So to choose that ideal pair, we need to see any. So if I choose 2 raised to power a and 6 raised to power b, so suppose if I take 2 raised to power 1 and 6 raised to power 1 and I add them, so that will be 8, which is an even number. Similarly, if I choose any power of a and b, any power, whether whichever you choose, a is equal to 2, b is equal to 2, a is equal to 3, b is equal to 3, that will generally give us the even number. So 2 raised to the power a plus 6 raised to the power b is going to be an even number, and similarly 2 raised to the power a and minus 6 raised to b is also going to be an even number. So even number multiplied by even number will give us even number, which is 28. So if you see these three pairs, both of them should be even numbers. So this is the case, this is the ideal case. We should write 28 as 2 times 14. So that is the ideal pair to write, ideal pair to choose out of these three pairs. So 2 raised to the power a, 6 raised to the power b, 2 raised to the power a minus 6 raised to the power b is equal to 2 times 14. Now the other confusion comes is which one should be represented as 2 raised to the power a plus 6 raised to the power b, and which should be represented as 2 raised to the power a minus 6 raised to the power b. So to choose that, if you see 2 raised to the power a plus 6 raised to the power b, if I choose a equal to 1, which will be 8, and similarly if I write the same equation 2 raised to the power a minus 6 raised to the power b, and if I put 1 here, so that will be equal to -4. So it means 8 is greater than -4. That means always your 2 raised to the power a plus 6 raised to the power b will always be greater than 2 raised to the power a minus 6 raised to the power b. So what that means is we should write like this: 2 raised to the power a 6 raised to the power b should be written as like this, 14 times 2. Why? Because this sum of the two numbers would be greater than their difference or subtraction. So now we will get two different equations to solve these two variables. So how I am going to write them? I'm going to form 2 raised to the power a plus 6 raised to the power b will be written as equal to 14, and 2 raised to the power a minus 6 raised to the power b will be written as 2. Now we will use the linear equation, two-step linear equations or two simultaneous equation to solve this. So I will be adding these two equations, right? So if I add these two equations, I will get 16 on the right hand side, and this 6 raised to the power b will be cancelled here, so I will get 0 here, right? And I will get 2 times 2 raised to the power a. So 2 times 2 raised to the power a equals 16. Now 2 raised to the power a is equal to 16 divided by 2. 2 raised to the power a equals 8. Now as we all know, 8 is 2 times 2 times 2. So that means 8 can be written as 2 cubed. So what that means is 2 raised to the power a equals 2 raised to the power 3. As we have got the base same on the both hand sides, 2 and 2 get cancelled, so we are getting the value of a equals 3. As we have in the question, it is given that a and b are positive integers, so a equals 3 here. Similarly, we will be solving, we can take any of the two equations here, and we can substitute the value of a and get the value of b. So I'm going to use the first equation, 2 raised to the power a plus 6 raised to the power b equals 14. So I'm going to put a equals to 3, 14, right? So I'm going to get 8 plus 6 raised to the power b equals to 14. 6 raised to power b equals 14 minus 8. 6 raised to power b equals 6, right, on the right hand side. So 6 raised to power b equals 6 raised to power 1. So this, both the bases on both the sides are equal now, 6 and 6, so that they get cancelled and we get b equals to 1. Now, so we have got a equals to 3 and b equals to 1. So these are the values of a and b from this equation. So we have solved whole equation by forming two separate equations by writing the left hand side in the factorized form using some exponent formulas, and by writing right hand side in the product form or the factored form. So we have got our answers: a equals to 3 and b equals to 1, where both a and b are positive integers. So I hope you like this video. Please share it as much as you can. So I will be coming up with the next video very soon. So thank you for today. Bye bye.